Yes, good morning. Okay, so in previous session we have seen the entity representation in the VHDL language. Okay, what for entity representation? To represent or to declare input ports and output ports. That is the purpose of the entity declaration. Then coming to another important part of the VHDL programming is architecture declaration. The architecture declaration purpose is to represent the internal logic. To represent the internal logic. But in the language, we have four ways to represent the architecture. Those are data flow style of architecture, structural style of architecture, behavioral style of architecture, and mixed. Mixed means combining above three, that is data flow model, structural model, or behavioral model. Okay, if you use more than one model, then it is comes under the category of mixed model. Now, first of all, let us see what is the syntax for the architecture declaration. That is, it starts with the word architecture followed by name of the architecture of entity name is. Okay, that is, for the architecture the user has to give a name. In general, the name is related to the digital circuit which you are going to program in. Of entity declaration, entity name, that is to which entity this architecture is concerned. Okay, so that entity name you need to write here, then is. After that, as per the syntax, the area is referred as the declarative area. Then after declarations, the word begin is there. After begin, the area is referred as statement area. Then finally end architecture name. Okay, so here we have two parts. These two parts separated by the word begin. Before the begin, from the architecture, before the begin, that part is referred as declarative part, whereas after begin to end of the architecture referred as the statement part. In the declarative part, the user can declare his own declarations. Okay, so some declarations like signal declarations, constant declarations, function declarations, component declarations, procedure declarations, like that. Various types of declarations are allowed in the declarative part of the architecture body. But after begin, the part is called the statement part. Here the statements are called as concurrent statements. That is, whatever the number of statements there after begin can be executed simultaneously. That's why these statements are referred as the concurrent statements. In the architecture body, there are different types of concurrent statements like signal assignment statements, instantiation statements, process statement. Like that, many types of concurrent statements are available in the language. In later classes, we can see what are the different types of concurrent statements are there. Then finally, end architecture name. Okay, end architecture name. So this is the syntax you need to follow while writing the architecture, whatever the style of the architecture. So I said that four styles are there. Whatever the style, the architecture body is like this. This is the syntax for the architecture. Okay. Now let us take one example, that is, say, half adder. Okay, in half adder case. Okay, so here you can observe that the four different styles of architecture body: data flow, structural, behavioral, any combination of the above three. Any combination of above three referred as the four different styles. Okay. Then coming to first of all data flow model, let us see how to write the architecture body in data flow style. For let us take an example of half adder. Okay, in half adder case. So if you see in half adder case how the entity declaration will be declared, that we have seen in the last class. Now we are going to see how to write the architecture body for this half adder in the data flow style. In the data flow style. And what I said, the architecture body represents the internal logic or internal view it gives. As entity declaration represents the external view. External view. What are the ports, how many ports, and what type of data the ports can accept. That information we have in the from the entity. Now from the architecture, the internal logic we can know. Okay, but in order to write the program in the data flow style, what type of information the logic circuit from the logic circuit means, that is Boolean expressions. If you know the Boolean expressions, then you can easily write the architecture body in the data flow style. Okay, now let us observe what are the Boolean expressions for the sum and carry outputs of this half adder. Okay, so already you know from the STLD what is sum expression, that is A XOR B. Sum expression is A XOR B, whereas carry expression is AB. Okay, sum expression is A XOR, actually symbol we are using while writing the Boolean equation. Sum equal to A XOR B, carry equal to AB. Okay. And also here you can observe that the entity declaration, once again here written entity with the name of the entity, that is half adder, is port of A comma B. So both input ports, one is named as A and another one is B, both declared in the same line with the mode in, and data type is standard logic. Similarly, the output ports sum and carry also represented in the same line, and at the data type is standard logic. Then end entity, that is end name of the entity, means half adder. Followed by this we have the architecture body. So the architecture body syntax, you know, it starts with the word architecture, then name of the architecture. Here I am giving the name is data flow, just DF, of which entity it is related to, half adder. Okay, so half adder. So whatever the entity name for the half adder is there, the same name you have to write. So here just A is placed, just there is a mistake, you correct it. Is then, so since in this in this program there is no declarations internally, that's why directly begin I am writing. So architecture begin, followed by in data flow style the concurrent statement is called signal assignment statement. In the data flow style the concurrent statement is signal assignment statement. The syntax of signal assignment statement is similar to the Boolean expression. Okay, so let us see what is the signal assignment statement for the output port sum, that is sum less than equal A XOR B. Sum is less than equal A XOR B. That means sum is the output port name. Since it is a signal, its assignment symbol is less than equal. Its assignment symbol is less than equal. Then as per the Boolean equation, there is a XOR operation between the inputs, that is A XOR B. Similarly, the carry signal assignment statement is carry less than equal A and B. Okay, so because the Boolean expression for carry is AB, the relation between the signals A and B is the AND operation. Okay, so that's why here the carry less than equal A and B. Then end architecture name, that is DF. Okay, so like that you can develop the architecture body in the data flow style. Okay, so it's clear. Okay, what is the architecture body syntax? Start with the word architecture. Architecture name of entity name is. Then if you have any declarations, you need to represent the declarations but before the begin. But after begin, the statements are the signal assignment statements since it is a data flow style. So that the concurrent statement is referred as signal assignment statement. Two statements here we have written because two outputs are there in half adder case. One is the sum and another one is carry. So the signal assignment statement for sum is sum less than equal a XOR b, whereas for carry is a and b. Okay, so finally end df. Okay, end df. What is df? That is the name of the architecture. Okay, so like that you can write the entity declaration and architecture body for every digital circuits. So these two are must for any digital system to develop the program in the VHDL case. Okay, so you can take the any another digital circuit and develop the architecture body in the data flow style. Okay, so what information we need to write the data flow model? That is Boolean equations. Okay, if you know the Boolean equations, you can easily write architecture body in the data flow style. Okay, so better you take the full adder network, full adder, and develop the data flow style of architecture for the full adder. Okay, so up to this I am going to stop this session. In the next class we can see any doubts in the data flow style, and next we move to the another style. Okay, thank you.